Good day everyone, I'm Maureen Piedades from BS Edma 3B and I will show you some strategies or different strategies in Pascal's triangle. So here are the different strategies in Pascal's triangle. The first one is diagonal pattern, the second one is powers of 2, the third one is power of 11, the fourth is perfect squares, the fifth is Fibonacci sequences, the sixth is Sierpinski triangle, the seventh is combinatorics, the number 8 is corresponding binomials, number 9 is binomial theorem, and number 10 is binomial distribution. So, let's start to discuss about diagonal pattern. So, the first diagonal is of course just once. So, here it is. The next diagonal has the counting number. So, it is 1, 2, 3, 4, 5, 6, 7. So, the third diagonal has the triangular number. So that is 1, 3, 6, 10, 15, 21. And the fourth diagonal not highlighted has the tetrahedral number. That is 1, 4, 10, 20, and 35. The next strategy is power of 2. If we will add each of the horizontal in Pascal's triangle, the sum of the first horizontal is obviously 1. Then the second is 1 plus 1 is equal to 2. Then 1 plus 2 plus 1 is equal to 4. 1 plus 3 plus 3 plus 1 is equal to 8. 1 plus 4 plus 6 plus 4 plus 1 is equal to 16. Then 1 plus 5 plus 10 plus 10 plus 5 plus 1 is equal to 32. Then 1 plus 6 plus 15 plus 20 plus 15 plus 6 plus 1 is equal to 64. Then 1 plus 7 plus 21 plus 35 plus 35 plus 21 plus 7 plus 1 is equal to 128. And lastly, 1 plus 8 plus 28 plus 56 plus 70 plus 56 plus 28 plus 8 plus 1 is equal to 256. So what do you notice about the numbers? The numbers double each time. The first row represents 0. So that is 2 raised to 0 is equal to 1. Then 2 raised to 1 is equal to 2. 2 raised to 2 is equal to 4. 2 raised to 3 is equal to 8. 2 raised to 4 is equal to 16. 2 raised to 5 is equal to 32. 2 raised to 6 is equal to 64. 2 raised to 7 is equal to 128. And 2 raised to 8 is equal to 256. The next strategy is power of 11. Each line is also the powers or exponents of 11. The first line is just 11 raised to 0, that is equal to 1. Then the second line is 11 raised to 1, that is equal to 11. Then 11 raised to 2 is equal to 121. Then 11 raised to 3 is equal to 1,331. Sorry. And 11 raised to 4 is equal to 14,641. Then 11 to the 5th is equal to 161,051. So, how that happen? Simple. The digits just overlap. So, as we can see, we have here 2 10. So, if we will carry each of them, then this one will become 0, and this one will become 11. Then if we will carry 1 to 5, it will become 6. So, the result is 161,051. The same things happen in 11 raised to 6. That is 1,771,562. The next strategy is perfect square. For the second diagonal, the square of a number is equal to the sum of the numbers next to it. So I will show you the real figure of Pascal's triangle. So if we will square 4, so that is 4 squared is equal to 16. So the number next to 4 is 6. So the number below 6 is 10. So 10 plus 6 is equal to 16. Another one example is 5. If we will square 5, it is 25. Then the next number from 5 is 10. So 10 plus 15 is equal to 25. So we can locate the perfect square of the natural numbers in column 2 by summing the number to the right with the number below the number to the right. So To discuss further, I will show you how the perfect squares of the natural numbers in column 2 happens. So here is the original figure of Pascal's triangles. So the diagonal is here. The next is 2. So 2 square is equal to 1 plus 3 is equal to 4. Then 3 squares is equal to 3 plus 6 is equal to 9. Then 4 squared is equal to 6 plus 10 is equal to 16. Then 5 squared is equal to 10 plus 15 is equal to 25. Then 6 squares is equal to 15 plus 21 is equal to 36. Then it follows. The next strategy is Fibonacci sequence. If we will make a pattern by going up and then along, then add up the values as is illustrated, you will get the Fibonacci sequence. The Fibonacci sequence starts 0, 1, and then continues by adding two previous numbers. For example, 3 plus 5 is equal to 8, then 5 plus 8 is equal to 13. So to discuss further, we will use hexagonal Pascal's triangle. So we know that Fibonacci series that start with 0. Then if we will add the previous number, then 1 plus 0 is equal to 1, then 1 plus 1 is equal to 2, 3 plus 2 is equal to 5, 8 plus 5 is equal to 13, 13 plus 8 is equal to 21, 21 plus 13 is equal to 34, 55 plus 34 is equal to 89. So if we will draw a line like this, we will notice we draw a lines which are coinciding top left of the hexagon. This line will help us to find Fibonacci series. So we can see the line doesn't cut anything. So it is 0. So the second one, 1 is slashed by this line. So it is equal to 1. The next is the third line slash 1 again. So it is again 1. Then the fourth line is last 1 and another 1. So 1 plus 1 is equal to 2. Then the another line is slashed by 1 and 2. So 1 plus 2 is equal to 3. Then another line, it is lost 1, 3, and 1. So 1 plus 3 plus 1 is equal to 5. Then another line, it is lost 1 plus 4 plus 3 is equal to 8. Then another line, 1 plus 5 plus 6 plus 1 is equal to 13. Then 1 plus 6 plus 10 plus 4 is equal to 21. Then 1 plus 7 plus 15 plus 10 plus 1 is equal to 24. Then 1 plus 8 plus 21 plus 20 plus 5 is equal to 55. Then 1 plus 9 plus 28 plus 35 plus 15 plus 1 is equal to 49. Then another strategy is Sierpinski triangle. So this is odds and evens. If we color the odd, this is the odd numbers, and even numbers, we end up with pattern, the same as the Sierpinski triangle. We have triangle here that is inverted triangle. We can make many triangle if we will continue this. The paths of each entry is also the number of different paths from the top down. Example, there is only one path from the top down to any one. So that is correct. Then, and we can see there are two different paths to the 2. So this is 1 going to 2 and then 2. So that is again correct. It is the same going upward. There are 3 different paths from 3. So if we will start, then going upwards, here is the 3, 1, 2, 3. So that is again correct.